The year is 2020, and finally, the world is starting to get enthusiastic about knowledge graphs. It was about time. We also see developers getting really excited to start building applications on top of knowledge graphs, which is interesting because it's kind of hard to find many developers who are excited about working with RDF. Granted, few developers exist who know about RDF, but those who do, well, they don't always like it. So what went wrong? In this talk, I will explain what we think the problem is, and we will sketch possible directions to solutions. I think the main issue is that we, as a scientific semantic web community, are living under the assumption that somehow developers will come to the RDF community. So we're waiting for them. We're waiting for them to come to us and pick up on 20 years of great research we've been doing. Except they're not coming. And the ironic thing is that they are not waiting for us. They've moved on. They're using property graphs and other technologies that are much more developer friendly, even though we have some good answers to some of the problems they are facing. So what's going wrong here? Well, I think that ultimately what we're seeing is the semantic web's new chicken and egg problem. We're quite familiar with it because we used to have the case where there were no applications available because there was no data, and nobody was publishing data because there were no apps. The issue we now have is there are no apps because there are no developers. And it's hard to attract developers when you don't have a development ecosystem. So how do we get out of this chicken and egg problem? Well, I don't claim to have the final answer, and maybe I don't have any answer at all. But this talk is mainly an invitation to think about this problem together as a scientific community. And what I'll do is I'll present an exploration into what I call development primitives. So the question is, what kind of useful building blocks can we give to developers and specifically front-end developers? This discussion is about an article submitted to the International Semantic Web Conference titled LDflex, a read-write linked data abstraction for front-end web developers. I'm Ruben Verborgh and I work at Ghent University IMEC in Belgium. I'm co-leading a research group on decentralized knowledge graph management, and this article was written together with my colleague Ruben Taelman. Read-write linked data applications are fundamentally different from typical web applications we use on an everyday basis. A typical web application will read predictable data from a single data source. And often is the same application that has written the data there in the first place, or at least the same developers. In other words, predictability is key. They know exactly what they'll get. Now, the linked data world is much less predictable. Because one, linked data can be anywhere on the web. It's distributed. This is inherent to linked data. Second, data can be represented in different data models, ontologies, vocabularies, and so on. So there's a high degree of heterogeneity. And third, you as a developer don't control the distribution of the data. Data can be read from different sources. It can be written to different sources, but you don't get to say which data goes where. So indeed, it's a very different world. It's a very different and more complex problem. And this, in fact, is captured beautifully by the words of Dan Brickley and Libby Miller, who wrote, "People think RDF is a pain because it is complicated. The truth is even worse. RDF is painfully simplistic, but it allows you to work with real-world data and problems that are horribly complicated." And this is, I think, what we're seeing. When people say RDF is difficult, or developers say, "I'm not going to work with RDF," yeah, because the problem you're solving is just a simpler problem. You know the backend, you know what to expect, so there's no point in having RDF. You can just ask for JSON, it will be much simpler. The semantics are understood, they're agreed between people. But if data comes from different sources, suddenly semantics have to be agreed by different people, and you don't always control them. So this is actually where it becomes easier to use linked data because it helps you deal with those problems. But there's of course the initial complexity of the stack you have to deal with. So what we'll look at next is the three fundamental W questions. What is it that we're trying to do? Well, first, what we're not trying to do is make it easier to work with RDF. This is not about embellishing RDF or hiding its complexities, real or perceived. This is fundamentally about how can we make it easy to deal with uncoordinated, decentralized linked data, which is a very, very different problem if you think about it. And when I say decentralized data, I don't just mean open data. It can also be private data hidden behind a login. It's data anywhere on the web. And also, it's not just reading, but reading and writing data everywhere. So why do we need solutions to this problem? Well, actually, building any kind of application requires tooling to communicate from the front end to the back end. And in the case of linked data, that tooling needs to be much more complicated because data can be in multiple backends and in different formats. So it's like we said earlier, it is a more complex problem, hence we require better tooling than whatever is available. And at the moment, there's hardly any tooling available to build client-side linked data applications. But importantly, what we really need is a higher level of abstraction. Because if developers start building linked data applications like they build traditional applications, they will code against specific backends, against specific vocabularies, ontologies, and so on. And as a result, they will have applications that are not sustainable because they've encoded very specific assumptions. So the tooling needs to have an abstraction layer that allows them to not make those assumptions, and the tooling should instead figure those things out at runtime. Finally, whom are we building this for? Interestingly, the semantic web stack was initially built at a time where web developer was still a pretty new and pretty unspecialized profession. Whereas nowadays we have front-end developers, back-end developers, and a whole lot of other specializations. Especially front-end developers are interesting because they know how to build engaging end-user applications, which is something that we traditionally have not been great at. They study users and they specialize in those things, but as a consequence, they know less about how data wrangling works. So they need easy APIs so that they can focus on what they do best. Let's focus our attention to common access patterns which typical web applications would use. For instance, a common task is displaying the name of a person, let's say the user. So here's a function that does exactly this. Fetch a document from the web, then parse the triples, and then you would look for the full name and return it. Why do they have to write this? Because in JSON, it's just 2 words really. So why do they have to write a full data layer on the client side, whereas it's actually conceptually a really simple operation? Because all the time they spend on writing this code is time where they're not focusing on the end user experience. So can we take this away from them? This is why we've designed a language called LDflex. And LDflex brings micro-expressions, very short paths to represent common access patterns of applications. So the whole function we've seen earlier in LDflex, it's simply user.name. And it does all of the same things. Of course, this expression is much easier to write and also much shorter if you want to reuse it in different components. Now you could be thinking, wait a minute, I can do this in Sparkle. Why invent something that looks like yet another query language? First of all, it's not a query language. It is embedded in JavaScript. Every LDflex expression is just valid JavaScript, so it feels very natural to developers. But even if it were, it's not the point. You can do anything in assembler or in a Turing-complete language. The point here is that we provide an abstraction, because the expression user.name is not tied to specific ontology or location of the data. So it means that those assumptions about ontologies and data location are not hard-coded into the final product. Which means that such applications will be much easier to port to different contexts. So basically what we're doing is we don't give the front-end developer knowledge that they don't need to know, because if they do, they will bind to it and the application will not function in a wider linked data environment. So that's the point. And yes, under the hood, an LDflex expression will be translated into a Sparkle query, but the translation is variable. Depending on the context, the translation is different. Now, how LDflex works is that basically it feels like a JSON LD object. We're just traversing an object, except it's not really what happens. It feels like a local object, but actually it's an infinite object that fetches data from the web. So developers can just pretend as if they're doing JSON, but what really happens is data is fetched. This online LDflex playground has a JSON LD context preloaded. I'm logged in as a test user Jane Doe. As a developer, I can get Jane's full name like this. Under the hood, it's actually just a Sparkle query executing. I can also easily get Jane's given name and family name because the JSON LD context has both preloaded. LDflex also includes the ability to write. For instance, here I'm changing Jane's name to include her middle name Mary. When we revisit the name, we'll see it has been updated. When we refresh the page, we'll also see the name updated in the UI because it has been written to the corresponding RDF document. Let's have a look at Jane's friends. There's 2 people, and we can also get their full names. Note how this expression translates into a 2-clause Sparkle query. Remember when I said that LDflex objects are infinite? Well, we can indeed use any node from the entire web as an object property. For instance, here I'm loading data from my own profile document. Behind the scenes, a query engine is fetching this document and extracting all the relevant properties. I can get a list of my friends and their names. Note again the corresponding Sparkle query. I can directly use any properties preloaded in a JSON-LD context or, via prefixes, use my own. Here's my blog and a list of all my blog posts. Here are their titles. Under the hood, this is a 3-part Sparkle query. Finally, even the like button at the bottom is entirely driven by LDflex read-write expressions. So let us look at how LDflex works based on a simple example. LDflex is a path-based language, so you can just construct new expressions by chaining them. For instance, here we have user.friends.givenname, which will have all of the first names or given names of the user's friends. Now the properties themselves, they come from a JSON-LD context. So in this case, friends could be bound to, for instance, fov knows. And given name could be bound to fov given name or schema given name or any property that you want. So it is like a JSON-LD object, except it's not really. Because under the hood, what LDflex does is it uses the proxy pattern. So it's a virtual object that you're not really traversing and just collecting every step along the way. The magic happens when you put the JavaScript keyword await in front of it. Await is a relatively new keyword which triggers an asynchronous execution. So the moment you put await in front of it, the expression, which is a proxy object, is activated. So it will translate the 3 parts into an actual Sparkle query. It will fetch the relevant documents from the web and process the Sparkle query against them and then give back the results. Now the cool thing about the abstraction is that it doesn't say how the query mechanism is supposed to be working. It could be federated query processing, could be link traversal based query processing. Developers don't even have to know about the JSON-LD context because you can just pre-activate one for them. So even though it looks like a very simple expression, under the hood there's a lot of things going on that eventually lead to the correct query answers. So this is how a simple expression can actually open up the whole web of linked data. To me, the most important thing about LDflex is not the thing itself, it's about the principles. The fact that LDflex is a development primitive means it can be reused in many contexts. Of course, we can just use it as part of regular JavaScript code. But front-end developers tend to use frameworks such as, for instance, React or Vue.js. And LDflex is a micro-expression language, so it's really easy to just place it into existing React code. It combines much more naturally than, for instance, calling a function to fetch data. This also goes into the argument of why not just use Sparkle. As we said before, Sparkle would bind us to a concrete vocabulary, but the other thing is that Sparkle queries are just longer. And length matters if you want to write a short React component. It is just easier to say user.name. It takes up less space on the screen than just writing a whole Sparkle query time and time again. There would be too much repetition if we had to do that over and over again. So a micro-expression language condenses whatever expression you want to the bare minimum needed to function. And this is how a language and an abstraction such as LDflex easily integrate with existing front-end frameworks, which is crucial if you want to have adoption. The key takeaway is that we as a scientific semantic web community should actively start caring about developer adoption. We cannot afford to wait for developers to come to us because they're not coming. They're already busy doing other things. The key fallacy we've held for the past couple of years is that somehow we assume that the hard part of a problem is at the 80%. We're solving the hard 80% because this is where the research challenges are. And it's up to the engineers to take the 20% and bring it to the developers. But this fallacy only exists because we're not looking into the 20%. Because if we would see that actually there's still many research problems in there. Building simple abstractions such as LDflex actually require a lot of research. Because the more simple the abstraction, the more complex the hidden machinery behind it. So this is actually a research challenge. But also, this really is about diversity and universality. We need to make linked data work for people who are not like ourselves. And if we fail to attract them, it's not going to be their loss. It is going to be ours. Because we really can use a more diverse talent pool within the wider semantic web community. We need people who can bring the semantic web to the end user. How can we get our research all the way to people? Well, we're going to need developers. So when we enable developers to build applications, they can show them to end users. And in that sense, if you think about it, enabling developers ultimately means enabling ourselves.